Welcome back to my channel. Now this video is the continuation of the previous video. We are going to go further and explore more about the topic periodic classification of elements class 10 CBSE. Now modern periodic table. What is modern periodic table? The modern periodic table was prepared by Bohr. It is also known as long form of periodic table. You must have heard name Bohr many in class 9. He he did many inventions in chemistry. So it is long form of periodic table or modern periodic table are the same. In the modern periodic table, the elements are arranged in the order of increasing atomic number in horizontal rows called periods. We place under each element all other elements having same valence electrons, so that all the elements having same number of valence electrons come in the same column called groups. Since the elements having same number of valence electrons show similar properties, therefore all the elements in a particular group of the periodic table have similar properties. Now you may get a question that why only groups have similar properties, why not periods? What is period and what is a group? Group is the vertical columns in periodic table, whereas this period is a horizontal rows in periodic table. Now we will see especially in the characteristics of periods and then groups in next video. We will just cover about characteristics of periods in this video. Now let us move further. Right. Therefore, all the elements in particular group of periodic table have these similar properties. It is obvious that the arrangement of elements in the modern periodic table is based on their electronic configuration. You have read many times that it is based on electronic configuration. The modern periodic table is shown here. Only half part is given. This is period 2 and this is period 3. We will have a slight discussion on periods and groups here. Okay, I will focus on this and I'll read out the information for you. Right. This is the modern periodic table, long form of periodic table. I'll just read it out for you. The horizontal rows of the elements in a periodic table are called periods. There are 7 periods in a long form of periodic table. The elements in a period have consecutive or continuous atomic numbers. Did you understand? Now they are telling that there are 7 periods in total periodic table and they have consecutive or continuous atomic masses of the elements. The number of elements in each periodic table is given here. First period contains 2 elements. It is called very short period. Second period contains 8 elements. It is called short period. Third period also contains 8 elements. It is also called short period. Fourth period contains 18 elements and it is called long period. Fifth period contains 18 elements and it is also called as long period. Sixth period contains 32 elements. Sixth period contains 32 elements. It is called a very long period. Seventh period contains rest of the elements. It is incomplete. So you can see the blanks over here. The number of elements, okay, this is somewhat important and little confusing. I'll make you understand clearly. See, the number of elements in a period is fixed, by the maximum number of electrons which can be accommodated in the various shells. Now what does this mean? So I'll just explain you for just and then I'll read it out for you. So if you take an atom, this is the nuclei, this is nucleus, this is the K shell, this is the L shell, and this is the M shell, and NO also will be there. So in the first cell, the maximum number of electrons which can be accommodated is 2, right? So in second shell or orbit, the maximum number of electrons which can be accommodated is 8, right? 1, 2, 3, 4, 5, 6, 7 and 8. In M shell, maximum number of electrons which can be accommodated is 32, right? I don't have to do 32 here. It's a time consuming method. I'll just write it here. Now it's clear for you. Now taking this as a standard for classification of elements, what did they do is, in first period is to be considered as first shell in atom. Did you understand? They considered first period as first shell of the atom, accommodated in which 2 maximum electrons can be accommodated. They put 2 elements in first period. In second shell, the maximum number of electrons which can be accommodated are 8. Therefore, in second shell, 8 elements can be accommodated. 8 elements are there. It's not accommodated, they are there. In third element, in third period as well, 8 elements. It contains 8 elements. Fourth period contains 18 elements, just as L shell. The sixth period contains 32 elements. In this way, taking our accommodation of electrons in an atom, they have done this classification. So I'll read it once again for you. The number of elements in a period is fixed by the maximum number of electrons which can be accommodated in the various shells of an atom. For example, the first period has 2 elements because the first electron shell, K shell of an atom, can take maximum of 2 electrons only. Similarly, the second period of periodic table has 8 elements because maximum number of electrons which can be put in the second shell, L shell, is of atom 8. So the figure 2, 8, 18, 32, etc. representing the number of elements in which the periods actually correspond to the maximum number of elements which can be put in various shells of the atom. So, representing the number of elements in various periods, this figure represents the number of elements in various periods. Actually corresponding, this is nothing but it actually corresponds the accommodation of electrons in the atom. Maximum electrons which can be put in various shells of the atom. So the first period starts with hydrogen and hence with noble gas helium. You can see in this figure. All other periods start with alkali metals like lithium, sodium, potassium, etc. and end with noble gases like neon, argon, krypton, etc. The first element of every period has 1 valence electron and last element of every period, known as noble gas, has 8 valence electrons except the first one, helium, which only has 2 valence electrons. From this discussion, we can conclude that it is the number of valence electrons in an atom of the element that decides which element will be first in a period and which element will be last in the period. For example, alkali metals having 1 valence electrons each, so an alkali metal is always first. Similarly, noble gas have usually 8 electrons.